Welcome back to the World Lens podcast. I'm your host, Michelle Evans, digital specialist at WTCI. Today, we're excited to be joined by another WTCI member company. Chad Schneider, the CEO and founder of Root3 Labs, is here. Welcome to the show, Chad.
Thank you, Michelle. It's a pleasure to be here. I really appreciate the invitation.
We are so happy that you guys actually were able to do this for us.
Yeah.
New member company, so I'm going to start things off pretty basic. The description on your website says that Root3 Labs is a device engineering and product development consultation firm. What exactly does that even mean?
Well, I do love that you're starting with a softball question. We are helping manufacturers to turn their ideas into prototypes and prototypes into finished products. And that's primarily research and development. It could mean a napkin sketch or something that is more substantial, and we're helping to develop those. So we're a multidisciplinary group of engineers, and we are inventing things with our manufacturing collaborators, clients, partners.
That's really cool. So what's the benefit of going through a company like Root3 Labs? Are you a replacement for an internal engineering team? Are you only doing smaller businesses, or do you really focus in on specific products?
Well, as consultants, we have seen a lot of projects. We've literally hundreds of development projects over the years, plus a breadth of previous experience. So that gives us an ability to solve a variety of problems, and hiring us makes the most sense when you have a specialized, complicated problem with deadlines and your current team can't meet the deadline for whatever reason. Our team is made up of multidisciplinary engineers, like I said, and so that means we have mechanical, electrical, embedded firmware experience, and if you hire an outsourced firm, then you're getting that team. It's cohesive, it's already built up, and they work well together, as opposed to hiring one engineer or hiring a group of engineers that are new to the company, new to each other. And so we are combining all of our experiences with each other, as well as having worked together for, in many cases, lots of years. And then I think one of the things that we think about is we spend a lot of time thinking about how to be most effective with our efforts. So when deadlines are tight, we can try to put more people on the project or more hours, but really there's a lot more to be gained by rethinking about the problem and the solution and carving away anything that's not absolutely important right now. So it's not always easy to figure that out when what is critical and what isn't. And every requirement came with good intentions, so carving them out might seem hard to do. And we ask a lot of questions, and that's we ask a lot of questions.
I mean, I imagine you would need to kind of get all the specifics to make sure that the product that you're developing is exactly what the client wants.
Absolutely. We want to make, at the end of the day, it is what the client wants. Our clients come to us, though, because we are able to shape that and help guide them for the difference between maybe what they want and the impact of certain things, how that impacts the price, the manufacturability, the assembly, the interface size and weight and things like that, battery optimization. So there's a lot of things that the client may have requirements around, but really don't know what those requirements, how it impacts the product itself.
Yeah, not sure how the sausage is made, basically.
Yeah, and it can have, you might think something is small and simple, and it can have a real impact on the actual product itself.
Yeah, I can see that. So I would imagine that the most interaction non-engineers have with a product design is something very basic, like personal 3D printers or something like Lego sets. Are there any similarities between those consumer-grade products and the process that your team goes through?
Well, the Legos and 3D printers are a great way for children to start learning about product development and the process of inventing things and building things and problem solving. They come up with an idea, they start to build with it, they figure out what isn't right, and they keep making changes.
Right.
That is a fundamental building block of the work that we're doing, but we are building things that are much more complex, and they are not just about 3D printing or assembling a Lego. It's a lot of it is those are the tools that we use. So the tools that we use include 3D printers, and I have been known to build Lego and erector set prototypes.
Nice.
But they are primarily just tools, and the expertise is really what drives the decision on how we're using those tools, the design that goes into that prototype, the shape and functionality of a 3D printed part versus something that has the strength and durability and functionality of something that will be injection molded or machined aluminum or something of that nature later on in the process.
Okay. So product development is clearly something that requires a lot of skill, as you mentioned. What are the top misconceptions that you hear from customers and potential customers about this product development?
I love this question because there are a ton of misconceptions. Very high on the list is the cost of product development.
Yeah.
So a lot of people have come to us with an idea that since something costs X amount of dollars, that it might cost a little bit more to have it custom made and totally customized, but really it's just a far greater cost than that. Then how complicated things are to make. Even when people come to us and say, this is going to be really simple, I know it's simple, and it's just so complicated to make something simple, for one, but also even when something is simple, there are so many steps involved and so many things to think about. I start to list those steps and the process of developing that product, and to try to give them a sense of the scope of what they're asking for, even when something is simple, and that helps give them some boundaries around it. Then there's the number of iterations that we typically need to build a good product. So I think I read James Dyson made 5,000 vacuum prototypes, which admittedly is a lot, but he started manufacturing after 5,000. And then WD-40 is well known for being the 40th formulation of the chemical. So that's some good examples. We typically, every time we're doing in the high single digits, and it depends on what the process is and what you call a prototype as to how many iterations we make, because sometimes we're breaking apart the overall system into subcomponents, and then we'll do really low resolution prototypes to identify what may or may not work in that specific problem, and we'll build things out of cardboard and duct tape, and we'll build them out of acrylic, which can be laser cut really easily, or 3D printed parts that won't be durable, but they help us solve that specific problem. And then we can start to integrate all those things as we go down the road. So there can be lots of different versions of prototypes, but not the full, well-developed full prototype of the thing. And then I think finally there's the value of talking to your customers and understanding the market. So there's a misconception that you know your customer best and you know the market and that you don't need to talk to them, or that if you talk to them, you can get 3 to 5 people to agree with what you're doing. And I think most people who have done this, the market research and the product development companies that are building the next big products, they are talking to hundreds or thousands of customers and understanding what those customers need, aggregating them into the least amount of functionality and features that they can solve a problem with, and producing that and finding out, how can you make this solve a problem that is painful for our customers and that they're willing to pay money for, because it's a lot harder than most people think to actually get a customer to part with their money for the product. So you have to make something good.
I mean, if it were really simple, everyone would be able to do it, right?
That's right.
You mentioned the process with your your customers, what is the typical collaboration process like with your clients? Like, how do you ensure that their vision aligns with the technical feasibility and market potential for their products?
So we are always asking our customers questions. We collaborate with them often. A project can last for many months, and we are working with them on a regular basis. We're meeting with them. We're having design reviews. We are doing concept development, and then we'll send that over to get reviews and make changes. And then we're producing documentation that will show them what we're doing, the calculations we've been working on, the assessments that we've been developing of why something works well and something doesn't work well, the impact of certain features of if you're adding something or you want to talk about a specific feature, how do you make that go into the product and what are the trade-offs? So we'll be talking to them constantly about those issues and then trying to get deep behind the what they've asked into the why they've asked it. So a customer might come to us and say, I need this part and it's going to do this. And then we'll start to understand or question why they need that part, why they think that is the best solution. And is there a better way to do it that we can develop that might be easier, or it might be better for the end product, or it might just be easier to manufacture? There's a lot of aspects to that. So it's a tough balance of we are asking a lot of questions and questioning things, and the balance is trying to make it a two-way relationship where the customer understands our intent is to make their product better, and not to just question everything they say. And sometimes they're just going to say something and that's going to be how it is because they have an aesthetic preference or some other feature that they really think that would be very important to their customer. And that is often the way that the project will go. And that's fine as well. If they have preferences, that's absolutely the case. So
I'm sure that can be a little challenging sometimes when you're like, this is probably not the best way to do it, but we're going to do what you want because it's your product.
Well, often it may not be a question of the best way to do it. It may be a question of the way that you prefer to do something is perhaps not the way I would do something. And we all have opinions. I mean, you dressed a certain way and you have opinions about that, and I dressed a certain way and I have opinions about that. And so mostly those decisions are about how the customer might interact with things, or rather it's not an issue of right and wrong. It's more an issue of which way you want to solve a problem. And those have never been problems of safety or any kind of regulatory issues. Anytime it's around that, our customers are very amenable to any recommendations we make when it comes to electrical safety or some other factor. But if it's preference, then they have a lot of opinions, and they should.
Of course. So what is the most outrageous thing that you have been asked to create?
So we have built a lot of outrageous things. So we've been asked to replicate the brightness of the sun, to spin lasers above a performer's head at 1,000 RPM, and to simulate the physical breathing rhythms of an infant that's sleeping on the bed. I think I'm paraphrasing.
Wait.
Okay.
What could possibly be the use for these things?
Oh, well. So I am not going to talk about replicating the brightness of the sun, but the spinning lasers above a performer was used in America's Got Talent a few years ago, and that was to create this light effect that looked like a cone because it was spinning so fast. It was looking like it was a sort of a solid cone of light. And then the breathing simulation was our customer had developed a bed that was so precise and sensitive that it could detect the breathing rhythms of a sleeping infant. And then if you imagine the breathing rhythms changed, then you could detect SIDS automatically.
Right,
You
yeah.
could detect they stop breathing, or some other factor that their breathing would increase dramatically was also a problem. So they could detect it so well that when they went to go demonstrate it, they couldn't just use a off-the-shelf something to show, but they wanted to actually produce the sinusoidal rhythms of a baby sleeping.
Interesting.
And the interesting part was it was so sensitive that if they had cables running to the baby from a computer or from a controller or anything, that it would screw up all the data. So they had to make it wirelessly adjustable and battery powered.
Wow.
And it had to last for an entire day at a convention hall for their demonstrations. It was kind of fun.
That is interesting. I mean, definitely not what I thought you were going to say when you told me the most outrageous things that you've been asked to create. That's definitely cool.
Yeah, we don't typically think about things as impossible or not. We think about the quote from Henry Ford, and maybe I'm paraphrasing, but whether or not you believe something is impossible, you're right. And we love those impossible requests because figuring them out is the fun of our job. And little known fact, if you want an engineer to do something, just say it's impossible.
Good to know. That's interesting. Like puzzling, like
Yeah.
figuring out puzzles. So Root3 Labs has clearly a unique approach to product development. Can you elaborate on the company's culture and mission? Like, how does this contribute to the innovative solutions that you provide? And also, what does Root3 Labs actually mean? Like, where does the name come from?
All right, so I'll start with the second first. The what does the name come from? So when you're developing a name for a company, there are a lot of factors that you have to think about. Just like we were talking about something so simple, and I had to think about what is the domain name going to be, and is it available? Is it something that I am willing to spell out 100 times a day on the phone for email addresses? Is it short? Is it easily recognizable? And I had to think about all these different factors. But importantly, I wanted to differentiate the fact that we're a product design company from an engineering research and development company in the sense that it's a mathematical not formula, but it creates the vision of a mathematical operator of something that is more technical than the typical. And so that was what I was trying to conjure in your mind when you think of Root3. Gotcha. And our symbol is a square root of 3, and it is based on that. So it was something that went into all of the naming. So that's the short version of how you name a company. And then your other question was about culture. And I think the biggest factor for culture is that we have a very collaborative environment. So our engineers are working together. They're not competing with each other. They're working together. They have various disciplines, but even among the same disciplines, we're learning from each other. We are spending a lot of time together. We have a primarily in-person environment because we work with hardware. It's really hard to be remote when you have, we have a really extensive machine shop and prototyping workshop. And so if you're working on a prototype, it's really hard to be remote. Even when you're working in embedded firmware or software, you're interacting with devices. And so you're writing code, and then you're testing code, and you're making things move. And so when you're on premises, you're constantly bumping into people and having them come over to your desk. And that collaborative environment is really important for generating a culture of a cohesive team.
Nice. I like that. Especially because it's such a hands-on type of field that you're working in. It does make sense to have everybody in-house.
Yeah, and the other part of that culture is the ability to solve what we would call, quote, impossible projects, is that we have a culture of embracing the failure of prototypes. So we build something, we try it out, it doesn't work, we move on to the next thing. We aren't trying to blame for anything. If you are trying something novel and you don't get it right, that is what we are doing. We are trying to solve sometimes what are understood to be impossible problems, and you're not going to just go and solve it the first time. That isn't what we do. People can ask us if we've worked on something before, and that is a question that we get a lot, but for the most part, the answer is probably no, because those things that have been worked on before have been invented, and there's less to know about that. But we've worked in a variety of verticals like microfluidics and microelectronics and large aerospace projects too. So there are definitely things that we have a lot of domain knowledge about. But if you're trying to solve things that are very challenging, complex, impossible, or quote unquote impossible, then there can't be wrong answers. There can't be blame when things don't go exactly as you thought they would. And the other part is in the brainstorming sessions, in the ideation part of things, even problem solving, I think that I've tried to instill in everyone that once you've set an idea, it's out there, it's not yours anymore, and so you are less likely to try to take possession of it and be defensive of it. So I'm pretty well known for throwing out ideas and then breaking them apart and finding out what's wrong with it. And it's the fun of it. Yeah,
nothing beats a failure but a try.
That's right.
All right, so you're talking about trial and error. Talk to me a little more about that. They're clearly experts at designing products, but what, if any, are the challenges that can really stop you before the physical product is in hand?
There are a lot of things. I mean, we've definitely found that there are aspects of functional performance that we just hadn't considered. We had a product that creates an electrostatic field, and any metal we thought we had covered so that you wouldn't shock anybody, but then there were paint with metallic fleck in it, and it was creating an environment that you could get shocked, and so we were not really aware or thinking about it at first. And so first prototype, we figured out that we needed to go with different materials, and then we went down the rabbit hole of the contents of the paint. Like white uses titanium dioxide and carbon uses graphite, and so there's lots of different aspects to the actual materials that go into paint that you have to consider when you're working with electrostatic fields.
I never would have thought about what is in the paint of a product that can actually affect it. That's interesting.
Yep.
So, as we have talked about this whole time, is that engineering is a process that takes a lot of time and a lot of steps. But, there's that Thomas Jefferson quote about not failing, but finding 1,000 different ways not to make a light bulb. Do you have any stories or lessons learned from your failures?
Well, Thomas Jefferson was an amazing person, but I think Thomas Edison.
Yes,
invented the light bulb, but the idea still stands, and we have a mindset that failure is temporary, and so we try to fail small. So a lot of times when you're building something, you don't want to just get to the end and figure out that it failed. You want to build something, test, build, test, and make incremental strides so that you didn't figure out at the end. And then there's integration of all these different aspects where when you fail, you don't actually know which part of that failed. Is it, a specific component or feature or functionality, or is it the integration of all of them that made it fail? So when we build something and it works by itself, and then you build something else and it works by itself, and then you put them together and they don't work, then you've identified where that went wrong. Yeah. And so it's easier to actually keep going in that route where you build and test and build and test, and you're constantly evaluating whether something's working, or just evaluating your assumptions and looking back and thinking about your assumptions, and is this true and that true, and how can we learn as we go. And that's really what I think is most important at figuring, failing 1,000 times and finding the solution in the end.
It's got to be satisfying.
Absolutely. It's like knocking things off the list. It feels really good to
check something off. I am right there with you. So what emerging technologies or trends in the medical device and defense industries are you most excited about?
I've been really excited about seeing the privatization of a lot of different aerospace aspects and defense, seeing that happening in the DMV, in the Delaware, Maryland, Virginia area where we're located. And it includes not only a lot of research and groundwork, but also launches are happening in Maryland and Virginia. And that launching of satellites, and there's just a lot of aspects of the industry that are growing and at a very rapid pace. And that's something that we are very cognizant of, is how we're able to move quickly and how private companies are able to move quickly by looking at what makes the most effect on your development path, what's most effective use of your time, and how do you get that done. And there's a big bureaucracy in government, and it is by design, or rather inherent in making an organization that has so many people and different agencies and different requirements and different needs to consider, whereas in private industry you have far fewer aspects to think about, and you're just worried, you're interested in the technical challenges, and that's how things move quickly. And so I really enjoy that.
How do you see Root3 Labs leveraging these advancements for your product development?
So we are thinking about how to, rather than leveraging our product development, we are supporting those industries. We're supporting the aerospace and defense industry and the medical device industry. And they might sound fairly disparate at first, but they're very highly regulated, and they're very complex, and they're also very functionality driven. So when things are intended to work, they have to work in all of those industries. There, as opposed to consumer products or other industries where if something doesn't work, you can warranty it, and you have failures, and you don't want too many failures because your customers won't buy your products. Things in these industries are functionality first, and that's what we really enjoy doing.
Nice. So for young engineers aspiring to work in product development, what advice do you have for them to succeed?
Internships. I loved when I was in school the internships. I recommend that all college students that they go out and they get internships. They work in manufacturing if that's what they want to do. They work in whatever industry they want to work in, and they go gain some experience, explore it, figure out what you want to do. Do you want to do financial consulting, or do you want to do manufacturing? Do you want to do planning and project management? Do you like product design or testing or HVAC? So there's lots of different ways to evaluate that while you're in school, and you can really set yourself up for success, because being a good engineer means being able to design something that can be easily manufactured and assembled and maintained and installed. And if you haven't ever built anything, it's really hard to be good at those. So if you just spend some time in a manufacturing plant and you go and you learn how something is made, if it's milled or if it's sheet metal or it's welded or it's electronics, and you're working on pick and place machines, then you can design a better product in the end, better prototypes. It's less expensive, it's easier to manufacture, it's faster. All these different things stem from an understanding of the things that are downstream and adjacent to what you're actually doing. So you can understand more about the industry as a whole than not just your job specifically. So
what skills and qualities do you guys look for at Root3?
We do hire interns. I like looking for curiosity. I think someone who has shown an aptitude for exploring outside their comfort zone, for working with maybe tools is a good, in general, working with tools, to build things, building projects, building hands-on things, whether it's in school, whether it's a personal hobby and project or an internship. It's a curiosity of learning new things, because you can't just sit back and let someone tell you what to do in college and here's the things you need. That gets you a foundational understanding of what the world is like today. But if you want to be relevant in 10 or 20 years,
dig deeper.
Or longer in my case, then you want to think about how are you going to keep up? How are you going to be working with those things? I don't want to be 80 years old and being the one who's calling my grandkids because I don't know how to do something, but there's still time to fall into that, I guess. So being curious and trying out a bunch of new things and exploring it and not being afraid to fail. I like taking things apart when I am not really sure how to do it, how it's going to go. There is a skill, I would say, and I had a lot of things that didn't end up going back together, and I'm sure my parents would probably say that's true more than most, but the skill is just trying to keep track of everything and then put it back together in a way that it came apart, and hopefully you'll be able to figure out what went wrong, and if it's broken, what could go wrong. It's already broken, so maybe you'll be able to fix it, and maybe not, and you'll just throw it away.
I love that. I like that. Chad, thank you so much for joining us today. And thank you all for listening. If people want to know more about Root3 Labs and connect with you, where should they go?
So we spend a lot of time on LinkedIn. And of course, we have a website, which is root3labs.com, ROOT, the number 3, LABS.com. It's not that hard to spell 1,000 times. And we would be happy to have people come out and see our shop. We have a very extensive workshop where we prototype things. We have a machine shop and a wood shop and electronics lab. So it's kind of fun to take a tour and show people what we're doing. And I love it. So I'd love to hear from people.
I love that. And everyone else, make sure you also visit WTCI.org and follow us on all social channels at WTC Institute. I will see you next time.